gotta be A.
What do you mean it has to be A?
It's
No.
A.
Do you even know the answer is C? Oh my God. Do you even... Okay. Let me ask you a simple question.
Do you love Einstein?
Yes.
Tell me.
Yes.
You do not love Einstein.
That's why
if you do not know, you don't know.
That's why our series is called what?
2BrosPhysics.
Okay.
How much did you have to? You little.
Let's look at our question today. Read the question,
I
please.
hate you. 2.4. Under what
Don't block
condition
this.
is the average velocity, which is a delta d over delta t, equal to the average of the initial and final velocities? I'm going to show you that it's A. Okay, let me explain over here.
Okay.
Under what condition is the average velocity
Use a
equal?
different color for the work.
Okay. So the average velocity,
No, erase that and then use the different color. Okay, good.
average velocity is delta d over delta t.
Okay.
We're looking at when that is equal to
Can you go to the other side so that you don't block? Go
Yeah,
there.
don't block.
the averages of VF and VI. Right? So
Okay.
VF minus.
Just tell me if you want to undo anything.
All the way down, Isaac.
Okay. So I'm going to show you how it's C. I mean A. So A must be acceleration must be constant.
Okay.
So
So wait, you think the answer is A?
yeah.
Okay, sure. Let's see.
So VF plus VI. So VF plus VI squared is equal to 2AD, right?
Yeah, sure. Okay.
Well,
Do you want me to take the lead?
Yeah.
So I
I
agree
want
with
you to see.
that the average velocity is displacement over time. But I want to draw a graph. Let's just stop blocking this camera. So I want to draw a graph.
Graph.
So when the
What?
acceleration is constant, what does it look like?
When the acceleration is constant,
What does it
then
look like?
it would look like this if we do this.
Yeah. Okay. Good. So if the acceleration graph, when you come here, it blocks. So if the acceleration graph looks like that,
Oh, sorry.
then what will our VT graph look like?
Well, our VT graph would look like a linear, constantly increasing graph.
Yeah.
No,
Yeah.
I don't want that color.
Okay.
It just doesn't contrast. It doesn't fit right.
So can you explain to the audience why?
Well,
If
If acceleration is constant,
Yeah.
then velocity will be increasing by the same value every single second.
Yeah.
So it's going to be linear and therefore not a parabola.
Yeah, how do you go from acceleration to velocity?
Derivative.
Uh,
Oh no, integral.
the integral. Yeah, so if you take the integral of the acceleration, you get velocity.
Velocity.
Yeah, velocity.
And vice versa, you can do when you do the derivative.
Yeah.
You want to know how this weirdo writes the derivative?
How?
This man writes the derivative like this. But he said everybody thinks he's
That's
crazy.
not the point. So this is the velocity graph, right? Now, if I want to find the average velocity, how can I represent that?
Okay.
So this is the initial velocity, and this, let's say, is the final velocity.
yeah.
So you just told me the average velocity is this, right?
No, the average velocity is delta d over delta t. That's what I
Delta
wrote.
d over delta t. But I can also represent it like this. I can
Yeah,
take
that's the requirement for
I can
right
take
now.
the average of the final and initial velocities. See, that's the average. And then I can draw this line, and look what happens. The area below this line
It's smaller than the area above.
is equal to the area above.
Oh,
That's why
not
it's
that
average
area?
velocity.
Oh, yeah,
Yeah,
this
you
is
see
equal
that?
to that.
So this triangle's area is equal to this triangle's area.
Sorry, I
That's
thought
why-
you were comparing this and that.
Yeah, that's why this is the average velocity. You see that?
Yeah.
This
Wait,
is
I
the-
want to show something weird as well. So if you draw this line here, then this triangle over here is also the same as this.
Yeah. So with that being said, this is gonna be what? VF plus VI over 2. So we just showed that if the acceleration is constant, then VF plus VI over 2 is equal to delta D over delta T, right? But what if the acceleration is not constant? if
But
acceleration...
that means A is not correct.
So let's see. If acceleration is not constant, then this A could look like anything, right? So then
Yeah.
your velocity graph could look like what? You wanna-
Anything.
anything. So
It's just the integral of...
imagine this is
That
your
don't think-
velocity graph.
That means acceleration is gradually increasing.
What would be the average velocity here?
The average velocity
If
would
this is
be...
VI and this is VF, what is your average velocity?
Well, let's see over
Uh-huh.
here. So, if you draw this line, and that's gonna be your average
make it
velocity.
straight. Make it straight.
Mm,
Try to make it straight.
mm,
Okay, and label it with the formula.
Okay, so this is
Don't
going to...
block.
Sorry, I can't... Sorry, I can't
Yeah.
write there.
Well, what is the average velocity formula you just wrote over here?
Sorry, just adjusting the camera. 1 sec.
Yeah. What is the average velocity formula you wrote over here?
The average velocity formula, that's VF plus VI over 2.
Okay, so that's exactly this one. It's the midpoint of the two velocities.
Okay, so VF plus VI over 2.
Now, do you agree with me? Does it look like the area under this graph is equal to the area above this graph?
No.
No. So does the average velocity formula work anymore?
No.
No, average velocity is not a good estimation.
I told you the answer was not C.
Doesn't work. Is there even answer C?
Yeah.
So,
C is for any possible motion.
but, so it is not C, right?
Yeah, but A must be constant. That means that my answer was
But,
correct.
but,
Oh!
there is one more scenario. One more scenario. You wanna see that?
Yeah.
It is still, A doesn't have to be constant. Look. You can make it so that the average velocity formula still works. Look. So let's say this is your initial velocity.
Oh, I get it.
Okay. Draw the average velocity
Let's say
in a
this
different
is
color.
the initial velocity,
Yeah, I'll give you blue.
and then this is the final velocity.
So what is the average velocity?
So this is the initial, and this is the average velocity. Now can I do it? Okay, so
But you're blocking.
I can't do anything, okay?
Fine.
If you keep saying, oh, but you're blocking, I will make this 2BrosPhysics the violent way. So, this area is equal to this area.
Yeah. But is it a
Sneaky.
constant acceleration?
No.
Exactly. So
Snake.
so that shows you some of the acceleration work. It doesn't have to be constant, but not all of the acceleration work. So what should our answer be?
B.
B. Yeah. You wanna circle?
So we were both wrong.
Yeah, we were both wrong, or we were both half right.
That's the positive way. I'm
Yeah.
always negative.
Okay.
B, only regular people circle. I highlight.
Wow. So read the answer.
Okay? The answer is, it's true for some, but not all motions.
Wow. Okay.
Wow.
That's it. Sit down. Okay.
So we both agreed on an answer. Let's hope we don't argue again.
Hopefully. B. Okay. Who is our sponsor?
Oh my god! The brilliant children are coming for me! Ambition plus MKO plus scaffolding equals learning. We believe anyone can learn anything. That's why our motto is memorization is a crime. And that's why we partnered with Brilliant.
Brilliant transforms math and science into hands-on activities so that you too can understand everything from first grade math to E equals MC squared. Barry Science Lab and Brilliant is your MKO and will give you the scaffolding to expand your ZPD until you become the next Sir Isaac Newton or Albert Einstein.
Visit brilliant.org/Barry Science Lab today And the first 50 of you to use that link will get a 20% discount on the brilliant annual subscription.
Don't forget that you too can become the next Einstein. So let's fall in love with math and science.